On this page, we're going to be applying the rules we just learned. So first off, we see that we are multiplying two monomials on the first one, so that's going to give you negative 28. We add the exponents, so I have x cubed and x to the negative fourth. If I add those exponents, I get negative 1, and then there is nothing else with the y, so it just stays y to the sixth. Now, when I say negative exponents, we know they mean division, so this helps you know what needs to move to the bottom of a fraction. The negative 28 does not. That's a negative number. It does not have a negative exponent. So this is going to equal negative 28y to the sixth divided by x, or x to the first. So I could put a 1 on that, but basically x is just a little more simplified. On the next one, we see a 0 exponent. There's a couple ways we can think about this. This is the whole quantity to the 0, so we know it's going to equal 1. If I distributed the exponent over multiplication, I would get 10 to the 0 times x to the 0, because 3 times 0 for the power rule is 0, and that would just be 1 times 1, which is 1. So the shortcut method to do it would just be knowing the whole thing is 1 because of the 0 exponent, but you could do it the other way as well. On the next one, I am going to add exponents again, so I'm going to put in a little 1 here. Negative 2 plus 1 is negative 1. 1 plus 3 is 4. This part is division, so I get y to the fourth over x. Now, when I see a negative exponent with division, I could subtract a negative and get a positive, but I find that it's easier to move that value first. Now, just to show this on the side, I will erase this in a second. If we're dividing by division, basically that means this x to the negative fourth means 1 over x to the fourth. There I have a complex fraction. I'm going to make a fraction in the top 2. That's 1 over 1 times, keep change flip, x to the fourth over 1. So when we have a negative exponent on the bottom of a fraction, it's kind of like double division, which flips up to multiplication. So we're just going to apply that, not have to think about it too much anymore. So when I see a negative exponent in the denominator, I basically just take it and move it up to the numerator and make it positive. So the original x to the sixth is there. I'm moving this up and making it x to the positive fourth. I add exponents, and this one equals x to the 10th. We see another case of that here. There is a negative exponent. It's in the numerator, so not quite the same thing. I'm going to move that down to the denominator. So I get 5y cubed over 10x squared y to the fifth, and we just move down x to the sixth. So for my numbers, that reduces to 1 over 2. Here, for the x's, I'm going to add the exponents, so that's going to give me x to the 8th in a second. Now, I can subtract the exponents here. I can also use the old way we used to do it, where I subtract the exponents and leave it on the bottom, the bigger one. So, no, whichever way you look at it, 3 minus 5 is negative 2, or we could just cancel these and leave y squared in the denominator. So in my numerator, I don't really have anything left except for 1. In my denominator, I have 2 x to the 8th y squared. The next one, both of these have negative exponents, so they're both going to move to the other side of the fraction. So I have x to the 7th over x to the 5th. Subtract the exponents, and I get x squared. That's not 1 over x squared because the 7 is larger, so that stays x squared. The next one, at any point when I'm multiplying, I could also just take this and move it to the bottom. I find that it's easier, such as in C, to just add the exponents first and deal with it later. When I have division, I find that it's easier to move those negative exponents. So it's just really a little bit of, decision making in terms of what you think is going to be more successful. So here, because it's just multiplication, I'm going to add the exponents. When I add the exponents, I get 0. So this answer is 1. The next one, we have the power rule. So I have multiplication. In the parentheses, I can distribute an exponent over multiplication. That gives me x to the negative 8th, y to the 12th. It's an equal sign. And we're going to move that to the denominator. So we have y to the 12th over x to the 8th. In letter I have power to a power. I'm not really distributing, so I'm going to multiply these exponents. So I get 6x to the negative 8th, negative 3x squared. Move the negative exponent. So now we have 6 over negative 3x squared, x to the 10th. I'm sorry, x to the 8th. We will have x to the 10th in a second. And here, this becomes a 2, say a negative 2. I'm just going to leave it in the numerator. That becomes a 1. I'm just choosing where to put the negative sign. So I have negative 2 over x to the 10th. My last three problems, it really does help when you have that distributive property of exponents over multiplication to write in the multiplication so you see where to distribute. Negative 4 cubed, be careful, sometimes when we're multiplying exponents we start multiplying numbers when we should be using powers. Negative 4 cubed is negative 64, and then we have y cubed over 4y to the negative 8th. Move it up. So we have negative 64y cubed, y to the 8th over 4. This reduces to negative 16, and we add the exponents. So negative 16y to the 11th. Here we have 12a to the 4th over 2a to the 30th. Numbers reduce to 6. Exponents, we're going to have a to the 26th left in the denominator. So we have 6 over a to the 26th. This one has distributive property. So this is positive 4, negative 2 squared is positive 4, a to the negative 6, negative 20, a to the 10th. And move this, so we have 4 over negative 20, a to the 10th, a to the 6th. And then we're going to reduce fraction, put the negative on the top. So I have negative 2 over a to the 16th when I add the exponents.